In lesson 10.2, there's a lot of writing because we are going to explore throughout this lesson and draw some conclusions. All right, so we're exploring the area of triangles. Our essential question, what is the relationship among the areas of triangles, rectangles, and parallelograms? So we're going to discover those relationships. Okay, so we need some grid paper, which we have. We don't actually need the tracing paper if we have grid paper. Some scissors, and a ruler helps if you need to make straight lines, but you can just use a paper edge. All right, on the grid, draw a rectangle with a base of 6 units and a height of 5 units. Now I'm actually just going to go ahead and do this on my grid paper because it's going to help me later on to have it right here. Okay, so a base of 6. So 1, 2, 3, 4, 5, 6. A height of 5. 1, 2, 3, 4, 5. Now we know why we need the ruler. Look at that line. It's terrible. 1, 2, 3, 4, 5, 6. A little better. And 1, 2, 3, 4, 5. All right. So 5 tall, 6 across. And so this is a parallelogram. It's also a rectangle because it does have right angles. These lines are perpendicular. Okay, on the grid, we did that. What is the area of the rectangle? So if you remember, area equals base times height. Our base is 6, the height is 5. So that means area equals 6 times 5, which equals 30 units. They didn't give us a unit of measurement, so we go with units squared. All right, so we have 30 units squared. Now, see, now they want us to trace the rectangle, but I've already got it here. Draw a diagonal from the top left corner to the lower right corner. Okay, so it should go straighter than mine. There you go, so straight. I'm gonna try that again on this one that I've already cut out. Okay, and I'm gonna go okay, so we've got a diagonal line. A diagonal is a line segment that connects two non-adjacent. Adjacent means next to each other. Next to each other. But this is non-adjacent, so they're not next to each other. Vertices are corners. So this is a vertice. This is a vertice, this one, and this one. There's 4 vertices on this shape. These are non-adjacent. They're not next to each other. These two are adjacent. They're next to each other. These are non-adjacent. So this is diagonal. All right. Now we're going to cut out the rectangle, which I've already done. Then cut along the diagonal line to divide the rectangle into 2 right triangles, because remember, all of these corners are right angles. They're all perpendicular, which makes them right angles. Here we go. We're going to cut along the line. All right. So now, okay, so now compare the 2 triangles. So congruent figures are the same shape and size. Are the 2 right triangles congruent? Are they the same shape and size? Yep, they are. If they can lay on top of each other and the bottom one disappears, that means they're the same shape and size. All right, so the answer is yes. The triangles are congruent. All right. how is the area of each right triangle related to the area of the rectangle? So what was the area of our rectangle? When it was together, the area was 30, right? Didn't we find that right up there? It was 30. So here's a triangle and here's a triangle. They're both exactly half of the rectangles, right? So this one is going to be 15 because 15 is half of 30. This one's going to be 15. Put them together and you get that 30 again. So the area of the rectangle, or the triangle, pardon me, the area of each triangle is half of the rectangle because we cut the rectangle in half. So our final conclusion then, what is the area of each right triangle? It would be 15 units squared. They might write it 15 square units. It means the same thing. These are the same. They're synonymous. Okay, so we've got our little triangles, and they each are half of the rectangle. All right, so explain how finding the area of the rectangle is like finding the area of a right triangle. How is it different? Well, in both cases, you multiply the base times the height, right? But with the triangle, but the triangle is half of the product, or the 6 times 5. So in both cases, you multiply the base times the height, right? We multiplied 6 times 5, but the triangle is half of the product, half of the total. All right. Analyze. Use because a rectangle is a parallelogram, its area can be found using formula area equals base times height. Use this formula and your results from the investigate to write a formula for the area of a right triangle with a base of B and a height of H. Okay, so if the area of a rectangle is 1/2 base times height, or I just said the area of a triangle. Okay, let's try that again. If the area of a rectangle is area equals base times height, the area of the triangle is half of that. Okay, so the area of a triangle is half of the rectangle, or area equals 1/2 base times height. That's our formula. Area equals 1/2 base times height. It's half of the rectangle or the parallelogram. All right. The area of any parallelogram, including a rectangle, can be found using the formula area equals base times height. All parallelograms, you can use that, whether it's a square, a rectangle, or you know, a slanted rectangle that looks like that's a parallelogram. You can use a parallelogram to look at more triangles. So if we cut out this triangle, if we could cut out this triangle and then lay it next to the hole here, I end up with a parallelogram, don't I? These two are parallel. These two are parallel. Therefore, I can use the area formula of a parallelogram and cut it in half to find the area of this triangle also. All right. Arrange the two triangles to make a parallelogram, which we did. Are the triangles congruent? Yes. If the area of the parallelogram is 10 square, this whole thing is 10 square centimeters, what is the area of each triangle? If the whole thing is 10, then this one is 5, and this one is 5, right? And explain how you know. When the parallelogram is cut in half, we're going to use the word divided in half. And the parallelogram was 10. It makes two congruent triangles, meaning congruent meaning they're the same, congruent triangles that are each 5 centimeters squared. I got centimeters from right there. That are each 5 centimeters squared. All right. Repeat steps A and B with this obtuse triangle. Okay, so this, I need to draw a parallel line to this one. And a parallel line to this one. Okay, so can we use our formula, area equals 1/2 base times height, to find the area of any triangle? Is it going to work for this one too? Let's say this one is, I don't know, 18. I'm just making up a number. The whole parallelogram is 18. How much is this triangle? How much is this one? Well, this is 9, and this is 9. So can we use this formula for all triangles to find the area of any kind of triangle, whether it's a right triangle like we did in the first case? This is a right triangle. This is an acute triangle because the angles are smaller than 90 degrees, which makes them cute. That's how I remember acute triangle. This is obtuse, an obtuse triangle, because this angle here is wider, bigger, greater than 90 degrees. So that makes that an obtuse triangle. Does this formula work for all 3 kinds of triangles? Yes, it does. yes for any triangle. A second congruent triangle makes a parallelogram when they are when their edges meet. When they are next to each other and okay. All right, moving on. Okay, last one. So trace the parallelogram, cut it into two congruent triangles, find the area of the parallelogram and one triangle using square units. We don't need to trace and cut it. If you want to, that's fine. What is our height? Our height is 1, 2, 3, 4. So the height is 4. What is our base? 1, 2, 3, 4, 5, 6, 7, 8, 9. So our base is 9. 9 times 4 gives us the area of the whole parallelogram, which is what, 36? So this whole thing is 36. So how much is each of these triangles? Well, this triangle is 18, and this triangle is 18. Let's see, find the areas of the parallelogram. Okay, so the parallelogram equals 36 units squared. One triangle equals 18 units squared. Do the same thing here. 8 times 10 is 80. So the whole thing, this whole thing is 80. Half of it is the triangle, 40 inches squared, and so on. Let's take a look at our notes. Okay, I filled up my whole desk with materials. Here we go. Okay, not much in the way of notes. So when you cut a parallelogram in half, it makes two triangles. No matter what the shape is, it will always make two triangles. So the area of the rectangle was 28. That means that each triangle is 14. Here, this is the example that we did together. The area of the rectangle was 30. Therefore, each triangle is 15. So therefore, the area of each triangle is half the area of the parallelogram. So the area formula for a triangle is area equals 1/2 base times height. All right, good luck.